convert degrees to radians. Okay, so here's the deal. Should we times it by pi over 180 or 180 over pi? Those are your options. Pi over 180. In other words, divide by what you want to get rid of. So like that, I want to get rid of degrees. How many decimal places should I answer to? 3.
In a question like that, would it be wrong to write it as a fraction?
No. Is that what you were thinking?
Yeah.
Yep. I can award you full points as well.
With some other questions, it'll be easier to round it down, or not round.
Yeah, like reducing something like that. Yeah. Okay, convert radians to degrees. So now, if we're in radians, we just have to times it by the other way around. So, does your answer make sense? Do remember the approximate numbers. So for instance, 3.14, because it's pi. You know that? What's approximate at the top? 1.5-ish, 4.7-ish, right? So thinking about 1.8, it's here. Does 103 degrees make sense then? Yeah. Okay, does that make sense? Okay, draw 8 pi over 9. You won't have a calculator. So what do I know? What's your reasoning here? This is what my brain would do. A full pi I would think of a full pi as a 9 over 9. So I'm not a full pi, right? I'm less than a full pi. So I would draw something like that. Okay, if you do this for me, then you lose a half a point. Okay, does that make sense? I need to see how did you get there? Because there's lots of ways to get there. I could have gone backwards. I could have done multiple rotations. Okay, so make sure you draw me the rotation and the arm. Okay, a circle has a central angle of 83 degrees, a diameter of 20 inches. Find the arc length. So this is a formula that I will have on your formula sheet for your test. So figure out S. Okay, so theta, so the angle 83 degrees, but what do I know about this formula? I don't really want that. I need to go to radians. So I need to change it to radians. Has to be in radians. And then R is the radius. Did I catch anybody? It's not 20. 10, because this is a diameter. Okay, Full out type, I need 3 decimals and a unit of measurement because it's a certain length. Okay, so make sure your rounding and your units are there for full points. Because that always sucks on an exam, because that's usually the easier question on the exam, and then I have to take off a half a point because of rounding and half a point because of units, and now all of a sudden you're at 50%. Okay? A circle has an arc length of 15 centimeters, so arc length 15. And a radius of 8. So figure out the angle in degrees. So I use the formula to figure out the angle, but every time you're using this formula, this angle is actually given in a radian. So again, how do you convert? So obviously those questions would be on your calculator portion, right? Because you would need your calculator for that. Okay, so this one says state a positive and a negative coterminal angle. So coterminal is when it lands in the same spot. So again, if right now it's the time 10:18, at 11:18, the minute hand's in the same spot. So that's a rotation of a full circle. So if I'm in degrees, what could I do to move a circle? I could add 360. So that angle would be in the same location if you rotated. So that number is positive. So now I need a negative number to get me to the same spot. So what could I do to get a negative angle? I could backtrack 360, right? So if you need a visual, this is the original 353. This is me drawing 713. And that's the drawing of -7. So they're all 3 different drawings, but the arm is always in the same position, right? That's what this is all about. Okay. Same idea, coterminal. So here we went ahead 360, we went behind 360. What do we do instead of 360? Because now we have to talk about radian language. We could do this, adding or subtracting 2 pi, right? That kind of moves us around. Okay, instead of 2 pi, can you make that into a fraction? Because I have to match with 13 on the bottom. So what would I need to move by on the top? 26 over 13. Okay, so I need to, let's try adding 26. Let's try subtracting 26. So that would be a test question, I would assume, where? On your not calculator section. You don't need a calculator to do that. Okay, so there's a positive answer and there's a negative answer, so it works. Okay, so next one, we're going to find all the coterminals over this domain. So we're going to be adding or subtracting values of, this is what the process is going to be, add or subtract values of 14 pi over 7, and I picked 14 over 7 because that is the number 2 pi. Okay, what's the highest we can go? 2 pi. So the highest we can do is 14 over 7. And what's the lowest we can go? Negative 21 pi over 7. So you know what? Our original is already too low. So we're never going to go lower than that. Okay, so we're going to be going in increments of 14. So what are we going to get to? Negative 16 pi over 7 would be the next increment. So I went up by 14. Would that work in my interval? Yes, that's an answer. That works in my interval. Hello. Yeah. Yes. That's good. Yeah. No, I was just a Saturday. Okay. Sorry. Okay, bye. Okay, go up another 14. What are you at? Negative 2. Does that work in our zone? Yep, that's in our zone. If you go up 14, 12, is that good? Yep. If I go up 14, I already can see I'm going to get out of the zone, right? I'm going to be past the high. So you have 3 answers there. Okay, so I'm not even going to go a next one because then I'm going to surpass what I am allowed to surpass, right? Okay, simplify the following expressions. So I do not need a calculator again for this question. So everything I've done here is no calculator. Okay, cotangent. XYR, cotangent. What can you replace cotangent with? did you pick x over y? Cosines, so you're really cute. What? X rated. Okay, two fractions. What do you do when you divide two fractions? Multiply, flip. What would happen here? Cancel, cancel. And now I'm getting an R over Y ratio, which matches which one of the 6? The flip of sine. So which one's the flip of sine? Cosecant. So there's my answer. Okay, question 8, XYR question that's not a unit circle XYR. Okay, so let's go Astica. You got to figure out where you are. So I know these two things. I know cos is negative, and I know sine is positive. So where would you happen to land if you needed those to happen? Are you picking number 2? Okay, connect a triangle to your x-axis, and then you have to put a -4 and a 7 on there according to what you have. So cos is x over r. Okay, I'm going to say this is a not calculator question. You don't need a calculator for this. We can do it. So I have to find the third side. So we're going to go 49. So I did 7 squared. Subtract 4 squared. So 49 subtract 16 is 33. Is that square rootable? Nope. So you leave it, square root 33. And what do you think about location? Should I leave it positive or make it negative? Positive. Yep. I'm just going to note that to myself just so I just remember. Okay, I checked. It's positive. Okay, cosecant. So which letters are we working with here? Opposite of sine, so we're going to pick r over y. If you're sophisticated writing, that's also an answer. That's me timesing by root 33. But I would accept both. Tangent is going to have a what letter over what letter? Y over x. And I particularly don't like writing negatives on the bottoms of fractions. This is very awkward as a number, so I just put it as a negative fraction. Okay, Astica, you should always check, because we're in this S quadrant, sine should be positive. So this is a sine function, right? So it's positive, tan should be negative. Okay, we have a point on it's on the unit circle this time. It has a y coordinate, it's in quadrant 3, so I can draw already. So here's my y coordinate. What else do I know about that triangle? I know the r is 1. It's on the unit circle. Okay, would you like me to work with fractions or do you want to blow it up? Okay, we want to blow it up. So if I blow it up, I'm multiplying it by 13. So I multiplied it 13 times bigger. Okay, 13 squared is 169 minus 11 squared, 121. So I'm getting 48. Yeah. Is that square rootable? No. So root 48. Positive or negative location? Negative x. Okay, I'm also just going to place this on the original in case I ever need it. This would be the original coordinate. Okay, so now it's all about figuring out what you need. So secant, I need an r over x. So I can look up my blown up one, r over x. That's a negative value. So I'm just going to write negative value, r over x. Bless you. And cotangent, what are we at? X over y. Do you know what's going to happen with these two values divided? This is negative and this is negative. So my answer is going to be positive. Okay, tan should be positive. So if tan's positive, obviously cotangent's positive. Okay, so always think about your astica, looking at your final answers. Did my positive, negative make sense? That's where I find most people lose marks, is their positive negatives. Okay, no calculator. Find the exact value of this. So we're going to have to go to our unit circle. We're going to go to 210 degrees. So we're going there. And what does cosecant tell me to do? So do you remember what we wrote on our cheat sheet here? When you deal with the unit circle, we avoid r. We just omit r. So if sine is just the y, cosecant is the y flipped. So cosecant is the y value flipped around. So here I am, negative a half becomes negative 2. So the what and the where. So cosine, the what is to figure out x, and the where. So you're going to have to do a bunch of rotations here. So 1 pi is 6. 2 would be 12. 3 pi would be 18. 4 pi would be 24. So I'm in quadrant 4. So I'm in quadrant 4, and which one has the 6 on the bottom? So I'm at 330 degrees. And then it told me to grab the x. The cos is the x, so root 3 over 2. Okay, so those were just one-steppers. So now this would be more like your test question, because you're going to have multiple things going on. Okay, so let's write down the what's on the top here. So the sign, the what is going to be to figure out y. The tangent, it's y over x. And secant is the opposite of the cos, so we're going to do x flipped. Okay, so those are the what's. What are you doing? Okay, so 3 pi over 4. So here's my 3 pi over 4. The what is the y coordinate. So root 2 over 2, but my math is going to tell me I have to square that value yet. We'll do it later, but here's the value, and we got to square it. Plus (17 pi over 6). So can we just backtrack here? Here is my map for over 6. 6, 12, 18 would be the one over here. So 17 would land there. Because I'm looking at this one, I just did the 6 markers, 6, 12, 18. So in here, so I am at 150 degree marker. That's where you're on. Can you take the y divided by the x? And then the last one, where? Negative 5 pi over 6. So you're going to go backwards, and you're not going to go a full pi, because 5, 6 isn't a full pi, so we end up being at the 210 marker. And the what is the x value flipped. Okay, so there you go. That is the values that you need. And here is where I get almost everybody losing their points. This is very hard for lots of people. This is a majority of the test deduction comes from here, the math. Okay, so go slow and steady. What happens when you square? Root 2 squared is just 2. And the whole number 2 squared is 4. Okay, I'm going to times and flip. Does anybody know just what happens? 2's cancel. Okay, so I'm going to times flip. The 2's cancel. If you don't see it, here's me working it out. Times flip. 2's, that will always be the case. Okay. Order of operations. There's an add and there's a multiply. So think about that. BEDMAS.
Are we just putting the negative on the top?
It doesn't matter because right now I just will work that out right now. Okay, so multiplying this first. First of all, when I multiply a negative by a negative, this part is going to be positive. So the top is 1 times 2, 2. And again, I said this is going to be positive, so I'm done with that. What is root 3 root 3? 3. Some of you, do you want to change this to 1/2 or just leave it? It doesn't matter. Whatever. Okay, how do you add fractions? Common denominators. So I'm going to turn them both into 12. So times by 3 is 6. Times by 4 is 8. Okay, so again, really focus in on positives, negatives, and focus in on fractions. I need common denominators adding, but not multiplying. Okay? Okay, so then I would say the majority of the test points are this. This is the biggest section. Okay, so question 1. We are going to use isolation. You see that strategy? Because there's just one variable. So that's where you would start. Okay, so remember right now that you did not solve for an angle. This is solving for a, what is this called? This is a trig value. That's not the solution. So now, do you recognize anything with the use of the unit circle? No. So we're going to have to figure out quadrant stuff. Okay, I don't work with cosecant, so I'm going to change it. Which one do I change it to? Sine flip. Astica, where are you? We are figuring out sine being positive. Sine positive. Okay, we're going to sine inverse. Okay, so we're going to have our calculator. What should we do at the top here on this question? Mode-wise stuff. Degrees. So we're going to need to be in degree mode. Bless you. Okay, this is not the answer yet, again. What stage are we at right now with this number? This is just a reference. So kind of remember your stages. You need trig value, then you need reference, and then you go into final. So yeah, it actually happened to be one of our final answers, because if you go that much past 0, or are you going to do a 180 minus on that? Would that make sense? Because you're less than 180. Again, looking 3 decimals. Whatever value I'm getting here, I'm just keeping it rolling in my calculator. I never take it out of my calculator. Okay? Okay, number 2, or number 12 here. This is a trinomial. I'm going to try to factor it. So it's a complex. So let's go, what is the FLA number? -10. I need to make an add to 3. So multiplies to the FLA number, adds to the middle. So it will work. Okay, so I'm connecting something together to make a 5tan and something together to make a 2tan. Do you see your connectors? So there's a 5tan connector and a 2tan connector. Okay, a couple side notes. I have to deduct if you used the wrong variable. So did you put tan x or did you accidentally write tan theta? Okay, if you wrote tan theta, I have to deduct you because I'm not using theta, I'm using an x variable. So you can't change the variable. Check, did you write equals 0 at the end of that? Because I'd have to deduct there as well. Okay, so I'm going to go tan x equals 2/5. Tan x equals -1. Okay, all that work would be for 1 point, because that's all grade 11. So you should know how to do that. All you're getting here is trig values. So not the answer, you're getting trig values. Okay, let's talk about 2/5. Do you recognize anything from the unit circle stuff? No, so we're going to ask to collocate tan positive. Okay, I'm going to tan inverse 2/5. Okay, grabbing my calculator, what should I look up for at the top here? What should I do this time? It's got to be between 0 and 2 pi, so now I'm in radians. So get yourself into radians. Tan inverse 2/5. Okay, again, it's going to just keep rolling through my calculator. I'm going to keep it in there. So 0.381 is one of the finals. And then this one, are we doing pi plus? We're bigger than the pi. Ask yourself if your answers make sense. This value here has to be somewhere between 3.14 and 4.7-ish. Remember this line? We always kind of remember 3.14, and we remember this one is about 4.7. So, yep, that number makes sense, right? Okay, last one. Solve for all real values. Okay, this one would be a complex trinomial.
Are we doing the -1?
Oh, yeah, that'd be a good idea. Thanks. Okay, sorry. We answered this one. Best to answer this other one. -1. Do you recognize that as a unit circle? Yes. Tan, you can only do it 0 and 1. Tan is negative. Can you pick the quadrants that you would be in looking? Here and here. How do you know where tan is at 1 or -1? What's going on? Y divided by x. How do you divide two things in math to make ones? They need to be the same. So there's an answer. 3 pi over 4. And where else would you divide y and x to be -1? 7 pi over 4. Okay, I'm just going to give you these factors because it does factor with FLA. I found a FLA number that also adds to -9. Okay, can I not do it this way though? Can we do it another way just to make a difference? Because we just did a FLA factor. What if it doesn't factor? Can we just practice that method? A formula, right? Okay, so this would be cos theta is our variable. Notice how I'm not putting theta equals, I'm putting cos theta equals. Because what is the first thing you always solve for? Trig value. You don't solve for angle first, you solve trig value. So -b plus minus the square root of b squared minus 4ac practice using the formula just in case something on your test doesn't factor. You always have that. Or even on this last one, if you're just like, I hate factoring complex, just use the formula then as well. It'll get you to the same answer. So you can see I did it factoring and I did it formula, but you can see that you get to the same place. So just make sure you have that formula practiced as well. So again, once you're there, you're about 25% of done the question. Okay, I'm going to answer this one first. Cos theta equals 5. I'm picking that because it's simple. What is my answer? No solution. Cos and sine can't go out of that one zone. And this one, do you recognize unit circle or do we go to our calculator? I recognize. So cos is negative. And I recognize that on a unit circle. So what am I doing? I'm looking for cos, so I'm looking for x values. So I'm looking for x values of -1/2. So right there, so I have this marker, and right here. Okay, what am I answering in? Because now the question just says, for all real angles. For all real angles, so what should I do? 2 pi over 3 plus 2 pi k kei. Okay, so a couple of just small pieces to your test, making sure you're always using the correct variables. So you can see here I was doing cos theta, here I was writing with tan x, okay, because the final answer would have been x equals, here the final answer would have been theta equals. Using different variables, make sure you're paying attention to that. Rounding, make sure you go 3 decimals. Make sure if you're in radian language, you're in radian language. If you're in degree language, you're in degree language. Don't mix them up, right? Stick to the language that you're working with. If I had answered in degrees, then I'm doing plus 360k. You know what I mean? So keep your language the same.